Well, hello. Here we go again. We have just finished another module of great content on describing common network architectures. Now we're going to walk through the review, and as always, please pause as I read each review questions to think about it and come up with what answer you would give before I walk through the explanation with you together. So here we go. Number one, access switches are only supposed to be used for important or critical devices. True or false? The answer is false. Truth be told, when you design a network architecture, typically really critical devices will connect up to the distribution layer. That includes devices like, hang on, let me finish drawing my access layer switches right here. Devices like routers that are connecting off to the internet. You might have a device like a firewall that is protecting the network from certain things and traffic's going through it, or IPS, intrusion prevention service, or most commonly of all is the big old servers that everybody's connecting to. The access layer switches usually connect the not-so-critical devices like end-user PCs, wireless access points, even printers. And I know that sounds like, well, wait a sec, printers seem kind of critical. Yeah, it's not one of those things where work stops if the printer goes down. Number two, a campus network is used to describe any network that spans multiple buildings in the same location. True or false? The answer is true. I know we all tend to think about a college campus just because we think of campus, at least in the United States. I'm used to just hearing campus equals school, but that's not true. A campus in the world of the network environment represents any place where you have multiple buildings in the same location. As you tie those buildings together with network equipment, you have built a campus network. Number three. A Spineleaf architecture is best used in what type of network environment? The answer is C, the data center environment. Now, there is a movement and a lot of I'd say emotion, as much emotion as a network engineer can have, around moving the Spineleaf architecture into every facet of the network environments that we encounter. However, it is designed for and often deployed in a data center environment. Rather than following the typical core distribution access layer hierarchy, which is designed for that up-down traffic flow, it stretches essentially a backbone to all the network cabinets full of servers that need to often communicate not just with the internet, but primarily with each other for huge amounts of data transfer. Question 4. Blank are private connections between businesses where one connection connects to one other site. The answer is technically leased lines. But I think we could have also taken T1 or E1 or similar connection. There's actually T3, E3, etc., etc. These technically are measures of speed. A T1 equals 1.544 megabits per second. An E1, actually, here, turn that arrow over here. An E1 equals 2.048 megabits per second. But those speeds are often delivered in a leased line fashion. Lease lines are probably the least flexible and most fading away, if that's even a correct use of that term. They are fading away in the modern network because there's far more efficient and cost-effective ways of delivering wider network connections. Question 5. What are two types of wireless access points you might expect to find in a small office environment? Choose two. The answer is autonomous and lightweight, or another way of saying standalone and controller-based wireless access point. In a typical small office, home office environment where that office stands alone, I would expect to see autonomous. That is, each wireless access point is configured on its own by the administrator. Because it works well. It's no problem. Administrator's happy. You can just go in, configure the WAP, and it provides the wireless access. The challenge comes in when you have not just one Soho environment, but hundreds of them, because maybe you have an insurance company where you've got all these small insurance offices and strip malls all around the world. Then the administrator is not so happy to have to configure each one of those individually, so they will set up a controller And that could be cloud-based. It's running from a data center. And all the access points then at each one of these Soho environments will report into the controller and download their configuration from there. That's considered a lightweight access point. It makes the bulk configuration a lot easier. Last one, question 6. What is it called when you store your servers and network resources in a private data center that you do not own? The answer is colocation. That's the word I struggled with in that video. I'm like, I got to make a question out of that. Colocation means you go into a data center, which is often a large building. Like in Arizona, we have Iron Mountain data centers, and we go into those. Or what was the data center I used before I moved a bunch of servers? There's a bunch of them. Just type in, go to Google Maps and type in data center, and you'll find some in your area. These are places where an investor will build a facility that has redundant power, has cooling, and there's all kinds of different quality levels, and they will rent you a rack of equipment. That is considered co-locating your devices there. Now, one could argue that the public cloud is typically storing your servers and network resources in a private data center that you do not own. I was thinking about that when I was like, do I put that answer in there? And I did. I put the answer in there because it's not the best answer. Public cloud is typically referencing Google Drive or Office 365 or essentially AWS, Azure, all of these different services that are using private data centers that are controlled by a large organization, and they just rent the service. They don't usually allow you to go to those data centers and actually install your own servers and network resources. As a matter of fact, AWS doesn't even tell you where their data centers is. It's secret. Regardless, there is such good stuff in this skill that you can pull out every day for the rest of your life as a network engineer, because we are always designing, reconstructing, rebuilding network architectures the right way. I hope this has been informative for you. I'd like to thank you for viewing.